So for heat transfer from the spreader plate here to the big aluminum base plate, thermal grease is the obvious solution. It's expensive and it doesn't come in a very large container. So I did a little bit of looking on the internet, and the links are at the bottom of the video. In one test, Nutella was used as a heat transfer compound, and it worked surprisingly well. The other thing that worked, and again, I'll link to Dan's site, is toothpaste. So I happen to have a 2 or 3 year old container of toothpaste. I've got some Colgate that I'm not using for anything, and that was actually going to get thrown out. So what I'm going to do here is get a prop. So from what I've read, the heat transfer compound is actually very good at displacing the air. That is the air gap between the two materials. So it's best to take the transfer compound and work it into the surface. So what I'm going to be doing on the bottom of this spreader unit and on the top of this, is just taking this old steel brush wheel and taking the toothpaste and working it into the grooves. The idea is that it will displace most of the air. It's a fairly large surface area on that heat spreader. It's quite a large surface area on this big chunk of aluminum. So I'm hoping that works for me, and we will document as best we can how warm the AC controller is when this is done. So there is the big aluminum plate after I'm done. I think I've got it plus or minus about 1 millimeter all the way across the area that the controller is going to be. And here we have the aluminum heat spreader on the bottom of the controller. I put the screws in, the countersunk screws in to hold the lid, but the lid's not in place. And this is where all the toothpaste is going to be spread. And then we'll spread the toothpaste on there as our cheap and dirty grease, I guess. So what we're going to do here is use I should be using the steel wool brush, but I don't have one of those. What I'm starting with the toothpaste, it's been warmed up in the microwave for about 35 seconds. And nice and soft and easy to spread. And the next task here, just try to wipe my finger off. Okay. And we're just gonna again start with the area right under the IGBTs. That's what these bolts will hold on. It would be silly to have the aluminum further apart because there was toothpaste in between. But then again, this whole toothpaste thing is kind of silly to begin with. I'm sort of doing this because I don't have any thermal grease, and this using the heat spreader there is very temporary solution. This is only for testing. I wouldn't use this for actual running. So the thing that I found out on the internet, that toothpaste is electrically conductive. Wasn't something that I've ever been interested in, or asked myself, or me. It's one of those things that came up in the research. But this would not be a good idea if the parts had to stay insulated from each other. But that's not the case. Aluminum on aluminum is, of course, going to be conductive. There need to be an insulation in between. It is a thermal transfer only. Squishy. I would like it a lot better if it was bolted down, but that's not presently an option. So I guess we will. I was expecting there to be a bead along this edge. There isn't. There's a bead along this edge either. So it may be that I didn't put enough toothpaste in that particular area. I'm going to lift this up, see what kind of. Yeah, we still have all the ridge marks from my finger. It's not thick enough. There's a chunk too. Try and scrape. That is showing, I'm not sure if you can see that, but the little mountainous section shows that there's bridging between the top and the bottom. But that should be as good a heat transfer as you can get from toothpaste. We will find out how well that worked during our next test. And that should wrap it up for the experiment. Well, wrap it up for the application of the experiment. We'll see how the heat spreading actually works.